game programmer in several companies, mostly on indie games. And when you create an indie title, it's important that you create beautiful, distinctive, but also performant graphics to make your game stand out. And URP, or Universal Rendering Pipeline, really allows you to achieve that without the need of hiring the entire team of graphics engineers, and even a simple programmer like myself, can modify that pipeline to achieve some eye-catching and nice effects. So this is what we are going to talk today about. I'm going to give you introduction to Universal Render Pipeline. Then I'm going to show you two demo projects: the Boat Attack and Lost Crypt. One is related to 3D, and the second one is related to 2D. Then I'm going to jump into scriptable render features and sorry, just one second here. Scriptable render features and custom passes. Then I'm going to give a brief introduction to post-processing and lighting and how it works in URP. And I'm going to finish with a roadmap. So let's get started. I'm going to start with brief introduction to Universal Rendering Pipeline. So before, when you created your games with Unity, we had just one built-in render pipeline, and it was not very easy to modify, although we exposed things like command buffer that allowed you to create some additional kind of features to your rendering pipeline. But it was more of a black box, and it was difficult to fit many, all different scenarios. And what we heard from the users, what we heard from you, is that many users want to create some custom solutions, right? They want to have the ability to extend the renderer and be able to implement their own ideas, some interesting combinations of rendering techniques. And this is really why we created scriptable rendering pipelines. And so we have this core, that's Unity C++ layer, and this is a performance critical part, and it's controlling various parts of rendering in Unity. And of course, we have our tried and tested built-in render pipeline, which is great, but it has some limitations. It covers forward and deferred rendering and covers a variety of use cases, but it's quite old. And the core focus now for our graphics team is the render pipeline C# API. It's publicly available, so you can grab this link, and if you're interested in to see how it really works, there is a publicly available source code for that, and it really allows you to kind of extend it and modify it how you want, really, and to make it adhere to your needs. And because not every team has some rendering engineer enthusiasts, or maybe graphics programmers, we supply you with two predefined render pipelines, that is Universal or URP. So this is going to be a topic of today's talk. And the second one that we have is HDRP, or high definition render pipeline. So Unity is investing heavily in these technologies and is going to rely on them in the future. So things like shader graph and VFX graph, they are all relying on SRPs. And you might be wondering if you are starting a new project, whether or not you should use URP or HDRP. So you should ask yourself a question: are you targeting only the most powerful hardware, like high-end PC, PlayStation, or Xbox, or rather you want your project to be available on multiple different platforms? If it's the latter, then URP is a great choice for you. And it's built with performance and cross-platform development in mind. So in many cases, it can be proved that it will run faster than a built-in render pipeline or HDRP. And it doesn't require any specifics from the target platform. So it can run virtually on any device that's supported by Unity, be it a mobile phone or high-end PC, PlayStation 5 or Xbox. And some of the features of the URP are beautiful graphics. So it can be either realistic PBR workflow. It can be toon shaded in game or even 2D. So we expose different type of functionalities to make sure that it can look visually pleasing no matter what you are creating. And performance is also critical here. It's very crucial because more performance allows you to render more objects on screen, that's some additional functionality, more content. So with URP, we take a lot of performance considerations into account to make it run as fast as possible. And of course, as I mentioned at the beginning, it has quite a large platform reach. So virtually any devices that's supported by Unity, AR, VR, PC, PlayStation, mobile, they're all supported by URP. So maybe you can start a game with PC in mind, but later you want to port it to mobile, iOS, Android, or maybe Nintendo Switch. This should be all possible with URP. Also, extensibility. This is really important because URP allows you to quickly extend the rendering kind of behavior and use something that we call render features and custom passes without the need to write any specific C# code to create custom behavior. So this can be proven to be very, very powerful. And I'm going to give you some examples of that later. Universal rendering pipeline is also a continuation of the lightweight render pipeline. So all the features that were available in the lightweight, they are directly transferred to URP. We've decided to rename lightweight to universal to better communicate the intent. So universal is to target many different platforms and be kind of used as a default option, be universal. Core systems, if you update from maybe built into URP, the update from built into URP is quite simple. However, it might be difficult to go the other way around. If you update to URP, change all your materials and then try to go back to built-in, this might be a little bit might require more attention. Manual updates are required for features like the use pass or shader.find. They're relatively old APIs and they'll need some more attention to upgrade. And the good news is that URP is supported from 2019.4 LTS onwards. And here are the platforms that are supported. So you can see that the coverage is pretty large, from the mobile devices to consoles, VR, AR. Just a quick note on the versioning number. If you install this as a package in your existing project, if you're using 2019 version of Unity, you're looking at version 7.x. If you're using 2020, you're looking at 8.x. And if you're using the alpha or beta releases of 2020.2, then you're looking at package version 10. And as I mentioned before, the additional advantage of using URP is that it allows you to use the shader graph. That brings this very nice artist-friendly workflow. So you can create your materials and shaders using the visual tool instead of writing, handwritten shader code. And also VFX graph that allows you to create hundreds of thousands of particles that are simulated on your GPU instead of the CPU. So that's it for the introduction part. I'm not now going to go to the demo projects, really, because there are two projects. One is going to be related to 3D. That's the one I'm going to start with. And the second one focusing more on the 2D rendering. So for the 2D, we have this demo called Obat Attack. And the Obat Attack is really production-driven development project. It's a vertical slice of a real-world boat racing game. It's targeted at desktop, mobile, and consoles. And it's a testbed for the new features. So if the graphics team has some new features to be implemented, this is like a great project to test the ideas and see how it would work with a real project. And it's a very great learning resource as well for both internal people at Unity and external developers like you. So this is a project that it's publicly available through GitHub repository. So later I'm going to share the link with you in a chat. And what's really impressive about Obat Attack is that it was created by just one person. So it's my colleague Andre. He's a technical artist, and it was only him working on that really. So it's quite representative of what a small development team can produce. So if you don't have too many resources, if you don't have too many, technical artists, you could achieve similar quality using URP. Some of the features that exist in a demo are shader graph. So we use shader graph for all different features here, like water, rocks, with the triplanar rendering. We have some custom shaders, some custom rendering features for the water. And really important thing to note here is that there is nothing special about URP in a way that, it doesn't use this demo. It doesn't use any custom build of Unity. It's like vanilla Unity binary and packages that are publicly available for you to download through the package manager. So that's really great. And it's quite heavy on shaders because it's a very, very beautiful demo, and it uses we expose some parameters for you. So if you want to play around with the water, you can easily tweak it from your editor. Many parameters should be exposed in the materials. It heavily relies on a shader graph. There's some geometry shaders and compute shaders. And so I'm going to show you now the demo itself. So this is Obat Attack. It starts with this nice sequence created with timeline. So we have different camera shots, kind of like a real board game. You usually start with the cutscene like this to give you overview of the track. After the game starts, gain the control over the boat. You also have some AI characters that are competing with you, and this is really it. So this is the boat. You can see that there's some buoyancy to the boat, like it nicely reacts with water. There's some ripples on the water, so the boats, they are leaving like a trace of the ripples and the small waves. And this project is available for you to download. I'm going to share a link later. So the core thing here in this demo is that it uses the URP, right? So if you know Unity, if you go to your graphics settings, you can go to see the universal render pipeline asset, and many things here are configurable. So you can toggle HDR on and off. You can enable and disable anti-aliasing. So sometimes if you target, maybe mobile device, you want to disable some features. If you target high-end console, you want to enable some features. If you target mobile devices, you might want to decrease the render scale to maybe something around 75% of the original scale. Or maybe if you're producing demo for your marketing team, then maybe you want to bump it all the way to 2, which would mean that you are rendering it twice as a resolution and then downscaling it to your native resolution. We have some lighting settings. You can tweak the shadows. So here, for example, if I switch to toggle this all the way to 4K, you can see that shadows are really, really crisp. If you don't have that much, processing power in your GPU, you can put it back to 1K. And you can set up your shadow cascades. There's some settings for post-processing. You can enable your SRP batcher, dynamic batching, and things like that. Another thing that's very useful is that you can set different quality settings. So, for example, if you, as I mentioned, you can target all different devices. You can set maybe low to target mobile devices, medium to target maybe PlayStation 4, and high to target PlayStation 5 and high-end devices like that. So as I kind of change to different this medium, high, and low, what I'm really doing is I'm selecting different render pipeline assets. So each asset is representing different level of graphical fidelity. So you can see that here on the low, the AA was disabled. On the high setting, we have anti-aliasing 2x, and we also have the high quality shadows with 4 cascades. So using these different pipeline assets, you can use them to define different kind of graphical fidelity levels. And the high could be targeting high-end platforms. Low could be targeting maybe mobile devices. One nice thing about this demo is that we included this custom day and night controller script that is controlling your directional light and some colors, like the directional light color, the directional light rotation, as well as some fog settings. So as we go through, like day and evening or morning to the evening and then to the night, we are sampling that gradient that I have in the sun settings, that is the sun color, as well as fog settings. So if we have a day, then it's this bright blue. If it's evening or morning, then we go to this reds, and to dark blue when we go into the night. So that's really nice, and you can use it as a reference for your own project. Some additional things that we have here are planar reflections. So these are the things that come as additional renderers to your render pipeline asset. And you can see that the effect here is that we have this nice skybox far in the distance, and screen space reflection that's reflecting the sky and the rocks and basically any like static or dynamic geometry in your scene. We also have this render feature that's controlling the water, and we also expose some things for you to control. Also debug modes for water effects and the caustics. So if you want to play around with that and see how the water was constructed for that particular demo, you can go ahead and try it yourself. There is also interesting shader that we implemented for the rocks and different parts of the geometry. So you can see that it reacts with the position of the object. So if I submerge it in the water, there is some foam around the rock when it's in contact with water. There is also some moss and some greenery on top of the rock, and it's basically based on the direction of the surface and the Y position, the height of that surface. So if you're interested in that demo, if you like it and anything that might be something that you are interested in, I'm going to share a link to that demo and share it in the chat. Let's see if it works. All right. Yes, and if you have any questions, there is a Q&A panel. If we have some time at the end, I'm going to go through the Q&A panel and see what kind of questions you have for me. The second thing that's also really exciting is if you're creating a 2D game, we have this 2D renderer that you can apply when using URP, and it adds some interesting features to a game, that is real-time lights, real-time shadows, and some post-processing effects. So this is a project that I'm also going to share with you. It's called The Lost Crypt, and it's basically like a vertical slice project that uses a variety of new 2D rendering features. And this character, her name is Sarah. She's just a simple 2D character with some horizontal movement and jump. She is rigged and animated using 2D packages, including her hair, the braid. Using the 2D physics. The environment, like these trees swaying in the wind, they are animated using the shader graph. It's quite dynamic. When you enter this cave, the lights are a little bit dimly lit. You have this water that's reflecting everything above it. You can see that if we approach this wand, it will play the cutscene, animate the skybox, and create this nice particle effect. So now, after this animation, after we collected that item, our character can go out of the cave and explore the world outside. What's really nice here is that the point light that's assigned to this wand is reacting with the environment. You can see that we have this kind of spirits, kind of like Princess Mononoke style characters. They also react with this 2D light. Also, there's dust particles, or the fireflies, you could call them. These particles also dynamically react with this wand. So here, let me show you the point light that the character is holding in her hand. So it's assigned into this game object of the wand. And with the 2D lights, with the point light, we create this nice gizmo that allows you to rotate the light. So here I'm adjusting the rotation, but also the angle of the light. So here I can adjust the angle. It kind of makes sense that part of the light is kind of occluded by the hand. We can bump the intensity up and adjust the fall off area to make the smoother transition between the lit and unlit parts. So here we can see that it kind of nicely adjusted this 2D light. One thing to note here is that as I move my character around, the environment reacts to the lighting. And although everything you see here is 2D, we apply a normal map to the surface. We apply the normal map to the background, and it kind of emulates almost like a 3D feel to it. So it's a very powerful feature and can really bring your 2D scene to life. Another light I want to show you is the global light. So the global light, it overrides, it adds light to everything in the scene. So here you can see I'm changing the hue value of the color. And it really is very similar to what you can expect from a direction light, or maybe the diffuse light coming from the skybox. Here I was playing around with the sprite light. So sprite light can leave this nice, it's like a light cookie almost kind of feature. Here I'm playing around with this freeform light. So freeform light is really interesting. It allows you to generate any shape really. And another thing to note about the 2D lights is that you can make them render to a specific sorting layer. So maybe there are certain lights that you want to render only, you want to light only maybe background of your scene. Maybe some lights you want them to be reacting with the foreground. Maybe some lights only react to characters. So this is really powerful, and this is what the target sorting layer really is for. So with the freeform light, you can create some nice shapes in your scene, and to create like light shafts like this one here, and it's a really, really powerful feature. Here I was playing around with the fall off intensity. Of course, there are like many different ways in which you can blend the lights. Here they are kind of blended in an additive way. So we are like adding two color values from both of these lights. And it's very similar to what we saw in Obat Attack in a way that we're using the URP. So URP requires this render pipeline asset. That's just an asset sitting in our project. And the only difference here is that we are using this 2D renderer. And this 2D renderer, it has some additional parameters like the post-processing. but otherwise it's the same. And if you're interested in this project, let me share the link to this one as well. It's available on the asset store. So if you want to get it, you have to go to the Unity asset store. Link here. If you're interested in creating a similar game with this nice light shafts with sprite lights, point lights in 2D, you want to see how the Lost Crypt was created, feel free to go to the asset store and check it out. The next thing I want to talk about is the concept of the scriptable renderer features and the custom passes. So with the universal renderer pipeline, we designed it to be very modular and extensible. It comes with a concept of a scriptable renderer. So a renderer defines what you could call a lighting strategy and supported rendering effects. And all renderers in Universal RP, they are all built on top of this scriptable renderer pass API. And developers, they can create, you can create your own custom renderer and plug it into the URP the same way as URP plugs into Unity. And you can extend any renderer with additional render passes. And the render passes, they are kind of like logical steps that composite effects on a frame. So here I'm going to show you 3 examples, really. They are relatively simple, but they get across the idea very well. To add your custom feature, this is very simple. You just need to go to your renderer, and in the renderer you'll have this reorderable list with render features. So you just click the plus button, add your feature, and that's pretty much it. If you want to create your own feature, you need to go to Create, Rendering, Universal RP, select the render feature, and this actually requires some C# scripting knowledge, but I'm going to share a repository with you that already has a couple of these that you can reuse in your project. So the first example I want to show you is a very common scenario where you have these characters that just run around the scene, and sometimes maybe this is your teammate and they are hidden, they are occluded by some large 3D object, and you want them to be still visible. Once they are occluded, you want to maybe replace the shader, replace the material with something else. So this is what this demo is going to demonstrate, really. So here when I press play, I'm starting with this very common scenario without any effects. So once the character is hidden behind the tower, nothing really happens because I'm using the default forward renderer. So I just have these guys running around the scene. Nothing to see here, really. So the first thing I'm going to do is go to my data, create a new rendering universal forward renderer. And with this forward renderer, I'm going to name it something like occlusion renderer. And I'm going to assign it to my renderer list in the URP asset. So now the only thing I need to worry about is how can I kind of create a filtering, and how can I add these render features to replace the material once I'm occluded by the tower. So the workflow is very simple. So for the filtering, we are going to globally disable the character layer, and I'm going to add 2 new render features. So I'm going to render all the objects. Let's name this feature Dita. So this will be the case when we are occluded by the tower. I'm going to override the material. So everything that's on the opaque queue and on the character layer mask is going to use this new material. All right, and this material is just a simple material created with a shader graph. you can see that there's this base color, the theme color, and the only thing that we modify here is the alpha channel, and the alpha channel is using this jitter texture that's provided out of the box, and we are just getting the screen position and mapping it on a screen position. So here, what I'm going to do now is in my renderer, I'm going to go and override the depth value. So now I'm going to render this over the material only when the depth value is greater. So it means it will render only when basically we are occluded by other object. So this is working, and let me add another render feature that's going to render the base color. So here again, we are looking for the character in the opaque queue, and don't overwrite any material. And on the depth, we are looking at the less or equal. So this will be our normal situation. But now the problem is that once we are occluded, because we are writing to the depth in the previous render feature, that was overriding the color as well. So after disabling write depth, we have nice and functional rendering examples. So now when these characters, when they hide behind any object, once they are occluded, the parts that are being occluded, they are using this replaced material, this jitter material. So as you can see, this didn't require you to write any code, and it's very, very flexible. You could modify the cues for rendering, transparency, opaque geometry, things like that. The next example I'm going to show you is from the FPS game. So here I have this is like the placeholder gun, and the really common thing with the FPS games is that we really want to have a wide field of view for the camera. Okay, so here the field of view is around 60 or even higher. But then the disadvantage of the really high field of view is that the gun, the thing that you're holding in your hands, it's going to look very small, relatively small to everything else in the scene. So we can use the custom render features to work around this problem and really create this nicely balanced gun and hands rendering. So here, what I'm going to do is something very similar. I'm going to go to create, rendering, universal render pipeline, and forward renderer. I'm going to name it FPS renderer, and I'm going to assign it into my renderer list. Okay, and in my renderer, now on the opaque, I want to disable the first person object, so that is my gun. So now what I end up with is I just render the geometry without rendering my hands or the gun. And what I want to do now is similarly like before, I want to render my objects, my gun, right? So gun, opaque. So opaque is part of the gun. I want to render it after rendering opaques. So this is the opaque queue, and the layer mask is going to be first person objects. Okay, after or before rendering opaques, this is what we have now. It should look exactly the same as before, but of course, right now we have only the opaque parts of the gun. We don't have the transparencies yet. To add the transparency part, what we have to do now is to add a new render feature that is going to be transparency. So let's rename it to gun transparent. And after rendering transparent, we are going to look at the transparent queue, first person objects, and basically draw it to the screen just like before. You can see that we ended up in the same point as before, so there's nothing special here. But the power we have now with this new forward renderer and these two render features is that I can override any parts of like the material or the camera. So I can override the camera field of view, and I'm going to decrease it to something around 40 for both the transparent and opaque geometry. So now the entire gun and hands, they are rendered using this render feature with different field of view. So that's really powerful. The example that we provide you with in the GitHub repository is actually a little bit more complicated because we have a setup of 2 players. So later I'm going to give you a link to that particular project so you can play around with it yourself. And the final thing I want to share with you in this part of the presentation is something that we call camera stacking. And it was one of the highest, most commonly requested features. And it allows you to overlay multiple cameras on top of each other. And a very common scenario is that you render your scene separately on a different camera, and then you render UI elements using a separate camera. So this is really powerful because it allows you to have this more modular game development workflows, and maybe UI team is working separately in a different scene. They use a different camera. So later, to composite all these different parts, it's much easier with camera stacking. Also, you can apply different post-processing effects based on the camera, different volumes. You can set up volumes per camera and things like that. So here I have this kind of dropship kind of scene, and I have this view from the inside of the cockpit, and I'm moving around the scene using the first-person controller. And you can see we have some interesting effects. We have this overlay with UI. We have some 3D geometry inside the cockpit. But the starting point I want to show you is here. So here we have just the first-person controller without all these bells and whistles. This is just, a camera moving in the environment. Nothing special here. And we are going to build on top of that. As you can see, the field of view is quite wide as well, like in the FPS demo. And here, what I'm going to show you first is I'm going to go one level deeper here. I'm going to enable this 3D objects for the cockpit. So you can see I have this kind of flying cockpit 3D model in the scene. This is viewed from inside of the cockpit. There are some interesting shader used to render this material from the inside of the cockpit. And the main camera that I was moving around before, instead of rendering directly to the screen, I'm going to render it to a texture. And to do that, I can set the output texture to my predefined render texture. So now instead of rendering directly to the screen, I render to that texture. And here I have a screen game object that's displaying that render texture with some additional cool kind of glitchy effects. So when I press play now, I should have the view from the cockpit together with my main camera kind of rendering. Yeah, so you can see that it's basically moving the entire cockpit together with everything. You could keep them separately, but for this quick demo, this is fine to move this cockpit together with the camera. And the next thing I want to do is to show you how the this rendering of the glitchy effect from inside the cockpit was done. So this was also created using shader graph. And what it really does is creating a set of UVs for sampling the texture, then splitting the channels to RGB to create this kind of chromatic aberration effect, and combining them to the final texture. So the UVs are being animated using this function there, and Here we have the final multiplication and output to the color. And the same shader is reused in different parts of the cockpit with the same shader, but with different property values assigned to the material. So you can see them here, like blur, exposure, things like that. And the final thing I want to add here is the UI. And the UI is the thing that I want to have the camera stacking functionality. So we could render it directly from here, but maybe you want to use different post-processing per camera, things like that. So I'm going to use a slightly different technique. Instead of rendering with the base mode, I'm going to use the overlay mode. So overlay mode, this allows you to reuse it in a stack. So on the main camera, I'm going to add, using this plus button, I'm going to add this UI camera. So it's going to render it as an overlay after rendering things with that camera. And it's really flexible because you could add multiple cameras there. It doesn't have to be one. You could press, the plus button, add additional UI camera. This is reorderable list, so you could modify the rendering order of these different cameras in a stack. So that's really, really flexible and powerful feature. And if you're interested in checking out this demo, it's available on GitHub. There is one more example there where we show you how to render outlines into your characters using two different techniques. So if you are interested in that particular demo, let me share the link with you in the chat.
Hi, Marek, can you hear me?
Yes.
You have 15 minutes.
All right, thanks. Yeah, I should wrap the presentation maybe five minutes, and then we can go into Q&A. So the final part will be the post-processing and lighting. So post-processing is really important because it applies this, after you compose your lighting, after everything is nicely lit, post-processing can allow you to give this final touch to your game. And this is really something that can make your game appear as, truly unique. And very often I refer to post-processing as kind of like a Photoshop beautifying effect to your real-time application, right? Because you literally take different buffers, like whatever you render to the screen, you just take it and make it appear more beautiful. So the post-processing, we call it version 3. It's basically now built into your URP. And this allowed us to create a tighter integration with the rendering pipeline. And if you want to blend between different post-processing effects, maybe a global effect, maybe you create some, like a cave scene where you want to use different lightings, you can use volumes for that. And volumes now also have some nice lighting information, so you can blend between different lighting settings in volumes as well. You can see that per camera, you have to enable post-processing on the camera. The anti-aliasing, it's set up per camera as well. And yeah, that's pretty much it. On the SRP, on your URP asset, you can modify the, because it's possible to render everything in HDR and apply color grading in LDR after the tone mapping. So this is something you can also set in the URP asset. As I mentioned before, you can blend between different post-processing effects based on volumes. So you can have one global volume, and then you can set up these volumes using the box colliders or any collider really. And you can set up the blend distance. So when you move your camera from the outside, towards the inside. It's going to nicely blend between whatever you have set up in your current post-processing with whatever is inside the volume here. There are many effects that we support currently, so this is the full list. It's quite a lot of effects really. The ones that I usually use is the bloom, vignette, and some basic color adjustments. So bloom is going to add this nice kind of dreamy effect to your scene, and kind of color spilling over the lens. Vignette is going to add some nice dark coloration around the edge of the lens to simulate the film look in your game. And if you create a mobile game, however, we suggest that you stick to the more basic effects like bloom, chromatic aberration, color grading, lens distortion, vignette, because these are the least computationally intensive calculations that don't require too much CPU and GPU processing, whereas things like screen space, ambient occlusion is going to require much more processing power. I also have a nice comparison of the performance improvements. So the red columns here on the graph, this is the post-processing version 2, compared with blue, the one that exists in the URP. So you can see that the one that we have in the URP is much more performant, and it's really great when you want to create the highest frame rate for a game and the most performant experience. So I'm going to finish with the roadmap. So this is just a quick overview of what's coming, what we have currently. Another very highly requested feature that we received from our users, is the screen space ambient occlusion, or SSAO. And what this effect really does is it allows you to simulate shadows in these areas where usually wouldn't be shadowed by just the directional light. So things like this connected pieces here, and some concave elements of your 3D scene. So this is something that we already have in beta version of the 2020.2. So if you get 2020.2 and get the latest URP, this is something that's already there. Another features that were already released in this 2020.2 are improved shader stripping. So when you build your experience for the first time, Unity is going to compile many shaders at the same time. So this might increase the build time. So this is something we improved with the latest beta release. So the shaders are going to compile. Basically, unused shaders are going to be stripped more effectively to decrease your build time. We added some nice features like the clear code map. So this is a thing that's very useful when you want to simulate maybe how the car will look like. So car has this very glossy paint, and clear code map, this is something that would allow you to simulate using URP. Things that are currently in progress are custom post-processing effects for this post-processing stack that we have in URP. Deferred rendering support, this is something that's also coming. And if you're interested in the full list of features that are currently in development, and you want to have a deeper, longer look at the roadmap, I'm going to share it in the chat as well. Share the link right now. And that would be basically it for my presentation. If you liked it and you want to see more content from creator advocates like myself or some of the Unity users, we have the YouTube channel for the Southeast Asia and Australia, New Zealand region. So if we have any webinars, we will post the recordings there. We have also Facebook. You can follow to post the links in chat. So that will be basically it for my presentation. And now we have 10 minutes left. So I'm going to go into the Q&A panel and see what kind of questions do you have for me? So yeah, I think the highest voted question was about the 2D game using URP and normal maps. So I'm going to take this question. So the question was, as said, for 2D game, URP uses normal maps for the sprite to for real light. So does that make the game more heavy? Do I have to keep anything in mind while using the 2D lighting? So of course, because of using this 2D normal map, you're going to slightly increase the build size of your application, but it's not going to be anything really significant. As for the lighting calculation, the calculations are still relatively simple to what we have in 3D rendering. So I think this is not something that you shouldn't be able to use in a maybe 2D game in on a mobile platform. But of course, every project is different. So what I suggest you do, maybe you can take the target device that you want to support. Usually, from my experience, that would be the lowest supported device that you have. Maybe your designer or your marketing team wants to support iPhone 4 or maybe Google Pixel, the first Google Pixel. Then I'll take that device and kind of stress test the scene, create many sprites using that feature, and see if it throttles your CPU or GPU performance. Another thing I would try is to create different quality levels. So as I show you with the Obat Attack demo, this is also something you can try yourself if you download the Obat Attack, is that you can create a separate rendering pipeline asset per quality level, right? So for things like low-end devices, middle and high-end devices, you could create kind of different settings. And for the beginners, there's another question that was highly voted, is as a beginner, where should I start learning about using URP? So I would suggest to go to our unity3d.com website and go to the Learn tab and go through the tutorials that exist there. Also our YouTube channel. So this is something I shared with you in the chat. I'm going to share all the links one more time. Yeah. So I would suggest that you go to our YouTube channel, go to unity3d.com and just go through the tutorials yourself. Another great way to learn any new technology really is to go through the samples. So we provide you with the Obat Attack sample, the Lost Crypt, and the universal RP rendering examples. We can go to each one of these projects, and you can maybe do some small alterations and like lights rendering. You can play around with that and learn based on that.
Hi, Marek.
Yes.
I think we are short of time.
All right.
So thanks a lot for your presentation.
Thank you very much for having me. It was really great to be here and join the event.
Thank you so much. See you in the backstage.
Thank you, everyone. Thanks.
Thank you, everyone. Bye.